Hello, today we're going to talk about bases. So bases are a set of numbers or a number used to represent our system of counting. We are used to normally base 10, which means if we were to take a number and break it down by place value, let's say we had the number 314. If we had 314 or 314 as we normally say it, this would mean that in the third digit spot, this would be 10 squared, this is 10 to the first, and this is 10 to the 0, or our units digit. If we wanted to break this down, we could break this down into 3 times 10 squared, plus 1 times 10, plus 4 times 10 to the 0. Or essentially, 300 plus 10 plus 4. However, if we were dealing with a different base, which we usually use this little subscript here, let's say we were dealing with this in base 6, we would actually say that this is 3 groups of 6 squared plus 1 group of 6 to the first plus a single 4. So this number is going to look very different. If we wanted to talk about 314 in base 6 and try to convert it into base 10, we would have to take 3 times 36, which is 108, plus 6 plus 4, which would give us 118. We use base 10 based on the number of digits we have, right? The number of fingers. However, you should probably know binary, which is base 2, or hexadecimal, which is base 16. A lot of those used in programming. Babylonians use base 60. Mayans use base 18 or base 20. And you could kind of have a different base depending on how you want to count, right? We could even think about our clock system as base 24 or base 12 if you want to do whole day versus half a day. So let's look at some problems. So what if we wanted to convert from one base to another? Let's say we have a number in base 10 and we want to convert it into base 5, for example. So there's 2 different approaches we can do here. We could either think about our powers of 5 and take away the largest power of 5 that we could have, right? So in this case, we have 5 to the first is 5, 5 squared is 25, and 5 cubed would be 125. So we know the 5 cubed is going to be too big. So we're going to take multiples of 25 away. So we would do 122 minus a 25 and another 25, and you guessed it, 2 more 25s. Because we have 4 groups of these, this means that our third digit spot is going to be a 4. So this would become 122 minus 100, which would just be 22. And then we would take away 5s, which we get 4 there. And then we would be left with 2, which would be our units digit. So one way is essentially taking away groups of the highest power you can until you get smaller and smaller numbers. The other way to talk about it is by dividing by that number. If we're dealing with base 5, we would then take 122 and divide it by 5. We would care about the remainder because that will tell us what we're essentially left with. So if I divide 122 by 5, this would go in 2 times. I'd have a remainder of 2, carry the 2 down, and then I would then go in 4 times, and that would give me 20. So I'd have a remainder of 2. Therefore, 2 would be my units digit. Then, because I still have a number left over, I'm going to divide once more. Right, so we have a ones digit of 2, or essentially a units digit of 2. Now we say 5 goes into 24 4 times, and that would be 20. We have a remainder of 4. So because 4 is our remainder, that's going to go in our second digit spot. And then lastly, we see that 4 is smaller than 5, so that would be our third digit spot, right? Essentially, it would go in 0 times with a remainder of 4 again. So let's try a couple problems with that. Taking these numbers, I want you to try to do the reverse, thinking about what this looks like with our place value. So thinking about this being essentially the third digit spot being groups of 5 squared, 5 to the first, and 5 to the 0. Try these 2 problems out, pause the video, and come back to it. Okay, with that logic, we probably realize that our first one would be 68. We essentially have 2 groups of 5 squared, which would become 50, 3 groups of 5 to the first, which would become 15, and then 3 singles. We add that up and get 68. For the second one, we have base 5 halves. And so that's going to be 2 times 5 halves squared plus 3 times 5 halves to the first plus 3. And that's going to end up getting us 23. We might not see that right away, especially because we realize here we're going to have fractions wherever we're dealing with this, right? We notice that anything after our first digit spot, we're going to have a fraction. That is something we're going to have to deal with. So dealing with 25/4 times 2, that will give us 12.5. This gives us 7.5. And then finally we have 3. So that gives us 23. Notice in this one, we have essentially a 3 as a digit, and we're dealing with base 5 halves. So here we actually have a number that is higher than our base power, right? 5 halves is 2.5. However, we realize that we're only going to move up per the next digit spot by having a group of 5, which means in this case, our highest value would be, our highest digit value could be 4. Once we have a 5, this 5 would essentially go together to become a 20. All right, let's look on to a couple more problems. Try this one. We're going to start with 254 base 6, and we're going to move it to base 4. Try to pause the video and try it out. Okay, we should have gotten the number 12224. Notice how I'm not saying 1,224, because those are all numbers based on base 10. Right? We have to treat this as 1224 because that's really the digit representation. It's not 1,000 because these aren't groups of 10. What I would probably do first in a problem like this is convert it to base 10 because that's going to be easier for me to deal with. So I'm going to have 6 squared times 2 plus 5 times 6 to the first and then plus 4. So that's going to give me 72 plus 30 plus 4. Or 106. Next, what I'm going to do is repeated division. So if I'm doing repeated division, I'm going to take 106 and I divide by 4. This will go in exactly twice, which gives you 8 and 2 6 as a remainder. Then 26 divided by 4 is going to go in 6 times, and I'll have a remainder of 2. So that'll be my units digit. Next, I'll take 26 and divide it by 4. That goes in 6 times, and that'll be 24. And that'll be a remainder of 2 again. Next, I take 4 divided by 6 and goes in once with a remainder of 2. And so that'll be my 3rd digit spot. And then I know 4 can't go into 1, so that's just my 4th digit spot. And we like to write our number with this little subscript to show that we're dealing with this in base 4. So this is 1222 base 4. Okay, so now we're going to talk about the products of 5-2 and 4-3 in base 6. So we're going to treat this kind of like a normal multiplication problem, except that instead of getting a group of 10 and carrying 1 over, this time we're going to have to get a group of 6. Because we're in base 6, anytime we have more than 6, that's essentially going to be a carry of 1 group of 6, right? We're going to essentially put that into the next digit spot. So 2 times 3 is 6. However, because we're in base 6, this becomes 0, and I carry a 1. 3 times 5 is 15. Plus 1 gives us 16. Well, if we want to do 16 in base 6, we essentially could say that that's 2 groups of 6, which would be 12, plus an additional, I'll say 12, and then additional 4. So this would actually be the number 240. Next, I'm going to do 4 times 2, which would give me 8. 8 breaks down into 1 group of 6, and then a remainder of 2. So the remainder of 2 will go over, and I'll carry a 1 here again from this 4. 4 times 5 is 20, and then 21. 21 can get me 3 groups of 6, right, which is 18, plus a remainder of 3. And so this becomes 3320. And just like normal addition, we're going to add here. We add vertically, and this becomes 0. 4 plus 2 is 6. However, that's one group of 6, so we'll carry the 1 and have a 0. Then 1 plus 2 plus 3 is 6 again. So we have a whole group of 6. Let's carry over that group of 6. And then 1 plus 3 becomes 4. So this number in base 6 actually becomes 4000. All right, problem 4. If A is equal to 0.4 repeated in base 6 and B is equal to 12.3 repeated in base 5, what is their product in base 4? Oh man, so we have a lot going on here, right? First, we might need to convert these to base 10. And then from there, we're going to want to try to deal with this if it were base 4. So let's look at what this looks like if it's in base 6. If I want to write this as a fraction, I can essentially say that x will equal 0.444 repeating. And maybe you've seen something like this if you're dealing with this in a repeating decimal in base 10. But because we're in base 6, we're going to not multiply everything by 10, but we're actually going to multiply by a 6. Now, if we want to, we can kind of treat this as writing it as a 6x, but I'm going to try to keep up with that base 6. So we're going to call this a 10 base 6, which is really 6. And so what that means is 10x minus x would actually be 5x, and 5x would be 4.4 repeating minus 0.4 repeating, which will actually equal 4. Therefore, x is equal to 4/5. We can do the same thing here with this 0.3 repeating. It's called 0.3 repeating equal to y. And again, we're still dealing with this in base 5. So this would be 0.333 is equal to y, which means that 10y is actually 5y, right? But that doesn't concern us, right? Because we're multiplying still. So that becomes 3.333. And now we get 3 equals, this becomes a 4y, because 5 minus 1 gives us a 4, and therefore y is equal to 3/4. So really what we have here is we have the following two numbers, right? We have 4/5 for A, so A is 4/5. And then B is, well, 12 3/4. No, I slipped up there. This shouldn't really be 12, right? Because we're in base 5. This number here is one group of 5 plus 2. So this is actually 7 3/4. So let's take this. 4 times 7 is 28, plus 3 would be 31/4. So now when we're looking at these, we can multiply these together and end up with 31/5. Now notice how this is all in base 10. This 3/4 I didn't need to convert into or deal with anything in base 10 because it was already in this fraction. If I had essentially had something like 3/1/4 base 5, I would need to change this 1/4 into a 9, right? And then deal with it from there. But because it's just a simple fraction, we're okay with that. Now we have 31/5 base 10, but we need to write that as base 4. So first we're going to convert the 31. 31 can be broken up into a 16. And then we would have, let's see, how many groups of 4 could we have? Well, we have 15 left over. And so we could say 3 groups of 4. And then we would have an additional 3. So this would become 1, 3, 3. We also could say this is 1 less than 2 groups of 16. And so really dealing with 200 minus 1 base 4, and that would give us 133. We also could have taken the 31 and done repeated division. That would have been fine too. Lastly, we have the 5, and we can tell pretty quickly that's just going to be 1, 1 in base 4, or essentially one group of 4 and a single unit. And so our final answer is 133 over 1, 1 base 4. Again, notice how I'm trying to not say 1,000 or 100 because that refers to groups of 10. All right, final problem. We're assuming B is positive, right? So if we end up getting a negative answer, we can throw that out. But we're trying to figure out what B is if 13 base B squared is equal to 202 base B. So we don't actually know our base here, but we can treat this as a binomial, right? We essentially have 1B plus 3, and we're squaring that whole piece, and that will equal to 2B squared plus 0B plus 2. So I can still double distribute, right? Or multiply that out however you'd like to, and get B squared plus 6B plus 9 equals 2B squared plus 2. If we want to subtract this left side over so we can use the zero product property, that would give us 0 equals B squared minus 6B minus 7, which factors down to B minus 7 and B plus 1 equals 0. So that either means B minus 7 equals 0, so B would be 7, or B plus 1 equals 0, so B equals -1. Well, we are told that B has to be positive, so our answer has to be B is 7. And we could check that out if we wanted to, right? If we were to change this all into base 10, this is really saying 10 squared is equal to 2 times 7 squared plus 2, or 98 plus 2, which is 100. So 10 squared is equal to 100. So hopefully this gave you some basics of bases and showed you some examples of how you could see this in contest. As always, if you have any questions, please reach out.